Having this chill kind of music is not conducive to waking me up, but I'm trying it out as an experiment. Let's see. So where did we leave off yesterday? Yesterday we were in the middle of trying to decode this weird algorithm. Hello, Dayloop. How are you? And we got as far as figuring out, well, we figured out one bug, and I think there's another bug, right? Was there? Yeah, so let's take a look at, every time we call, we should be able to see exactly what we're calling with. So grep call like this. Oh, that's a tough one. Oh, these are all the calls? There we go. Yeah, this is the beginning of it. Okay. And I think we had some bad code here. Right? We attempted 2 different algorithms and we failed both times. And I'm thinking, well, let's try a third time. Let me try, instead of... So I was thinking about this offline a little bit, and I was thinking, well, maybe we should just make a struct that contains everything instead of doing this lazy static thing with the unlocks and the unwraps and all that kind of jazz. Maybe what we could do is non-working version. This way we archive this, and I'm just going to start over again here. Boom. Let's create a struct. Call it a search struct, because we know we have R0 and R1. I guess I should introduce what I'm doing. The Synacor challenge. We've gotten 6 of the 8 codes, and we found a code yesterday that was not a valid code. So we did that by hacking our virtual machine to skip over the validation check that the code is doing. So we need to actually come up with the correct value for the R7 register. Here's R0, R1, and R7. Right now we're just putting in a 1 for R7, but it can take any one of 32,768 values. So we just have to figure out which one is the right one. We always start with 4.1. That's something we learned a couple of days ago. So what should go in this search struct is we're going to memoize things. So we're going to have a memo with the hash map. Oh, Dusty Pawsey, hi, how are you? Yeah, we spent all day yesterday trying to figure out the R7 register, and hopefully today we learned enough yesterday to get it. So we're going to take pairs. This is going to be R0 and R1, and I'm just rewriting the code from scratch here. I have a previous version of it that I'm just blowing away here. And then we have whatever R7 value. Oops. Yeah, R7 value, and it's a U16. What else needs to go in here? I don't know. We'll figure it out. And then impl search. So the new search, we'll just return a search of, I guess we can just say default. Which means we want to derive default. Oh, and we need the hash map. Derive default. Okay, and then main. What we'll do is, here's what I'm thinking of doing, is just saying for R7 in 1 to 32767, right? That's as high as we can go. We'll create a new search. We need to pass in the R7 value. And so we'll just say R7 default. And then we'll pass that in, R7, and then we'll say s.find, let result. Here's what I'm thinking the interface should be, s.find, and then we'll say if result.0, because I'm doing these tuples here, is 6, right? We remember this from a couple of days ago, is that the 0 register has to, the R0 register has to be a 6. And if it is, then we found an R7 result that works. For R7 equals this, result is this. I guess we can just print out both values. Doesn't hurt. R7 and result. So this is the interface I'm thinking of, and now we need to just write the find function. Oh, but we want to pass in, right? We want to pass in the registers. I'm going to start with 4 and 1 because we need to pass these in as register parameters. You know what? I'm going to do this. I'm going to say type. How about just regs, like that? That way, this is a map. It's clear this is a map. Whoops. From a pair of registers to a pair of registers, and we'll just take in regs, right? And that way, reg.0 is register 0, and reg.1 is register 1, and it all makes sense. And now I've forgotten the algorithm. Here it is. Okay, so the first thing we want to do is say if self.memo.get, right? If let some return value is self memo get reg, then return ret. So that's the memoization part. Then we're going to say if reg.0 is 0, then we're going to add 1 to, okay. Devka J, hi, how are you? So we're going to add 1, we're going to return, okay, first we have to memoize it. So let ret is regs is equal to, R0 is going to be reg.1 plus 1. Oh, right, but we have to deal with overflow, right? So we want to say and OX7, right? Because the values can only go up to 32767. And the U16 goes all the way to 65,000. So we can do this add won't overflow. And this will wrap it around to 0 if necessary. And then just R1, reg.1. So that's the return value. So we're going to memoize that. Self memo insert, and we're going to insert reg is going to result in this return value and the return ret. Okay. So I think that covers this part here. And then if R1 is 0, we're going to subtract 1 from R0 with overflow, right? But we know that R0 can't be 0, so it doesn't matter. We can just subtract 1, because if R0 is 0, we wouldn't get this far. I'll just put a comment here. Reg.0 cannot be 0 here. So we can just subtract 1 directly. And then we're going to call ourselves. It's going to be, oh, this has to return regs. Right, so we're going to say self find, oops, and we're going to pass it R0 minus 1 and R7. And we're going to memoize that. Self memo insert reg ret return ret. Okay. I feel like I'm getting somewhere now. Otherwise, if register 0 is non-zero, we jump here. Register 1 is non-zero, we jump down here. So now we're going to start with this line here. Push R0. This is just saving R0, which is fine. That's what we're going to do anyway if we call it. So we're going to subtract 1 from R1 and leave R0 alone. So let's ret equals self memo, oh no, self find. I was looking at the wrong line. Reg 0, and we know that reg 1 can't be 0. 0 here. What am I doing? Okay. So we know we can subtract 1 from R1. Reg.1 minus 1. Now what are we doing with that result? We're setting R0, we're setting R1 to the value of R0 and then restoring R0 and then subtracting 1 from R0. So I think this boils down to, we take the R0 out of this guy, this return. So ret.0 goes into R1. Okay, just comment here. Ret 0 gets moved to R1. R0 is left alone because we didn't change it here. This did the equivalent of the push pop. And then, oh, and then we do R0 minus 1. Okay, so I think that what that boils down to is self find reg.0 minus 1 and then ret.0, right? And we just ignore ret.1, we don't need that. And then we're going to call, that was the call, and now we're going to return ret. So self memo insert reg ret, return ret. And now I want to also log every call. So we can watch to see if it matches the same call sequence as here, and that's how we can debug it. So reg. Does this check? Nope. Oh. Like that. Oh, found a reference. Okay, I gotta deref it. Okay. Wow. Okay, that was pretty straightforward. Let's cargo run this, and then just pipe it into head minus 30, I guess, just to see if we're getting some values that make sense. 4140 3130 2120 1110 0102 13. Oh, look at that. I think we got it. Uh-oh. No, 24 23 22 2120, and then I have 15. And it should be 11. Oh, so we have a bug. Why are we doing 15 if we're passed in 21? Oh, that's that might be the first time we got a memoized value, right? Let's see. Oh, it isn't. That's the second time we got a 1. Oh, we do have a 1-1 here. But this 2-1 did get memoed. So maybe we were able to skip over a bunch of work because we saw the 2. We already know the return value for 2-1. Okay. So we might actually have something that works here. I don't know how long it'll take to run. I'm going to comment out the prints. So let's see if we actually get a result. I guess we can say cargo run release. I wonder how long this is going to take. Just bear in mind, this is my third attempt at writing this. I wrote 2 different versions yesterday, so I'm not feeling too confident about this version today. Should I kill it? And and then maybe I can print out a running total. As it's running, we can see what values of R7 we're looking at. I don't know how slow each iteration is, so I'm going to kill it. I probably, it's probably just about to finish, right? So let's print out print bang R7 \R, right? Oh, I bet you we're going to have to flush the output as well, right? Yeah. How do you do flush in Rust? Rust flush standard out. Looks like I've searched for this before. We need write and standard out, and we just call standard out flush. Okay, that's simple enough. Use standard IO write and standard out, and then we'll just call standard out flush. That checks. Why is this? There we go. Okay, so, oh, we have 2 warnings though. Oh, I bet you it's... Oh, okay, we can just throw that away, right? That's better. Cargo run release. Oh, it's running fairly fast. Let me make the cursor hidden. Is that about 100 per second? Maybe? In which case it'll take about 5 minutes to run through all the possibilities. Is it worth trying to speed it up? I mean, this is supposed to be a programming stream, not a watching numbers go up stream. So maybe it's okay if we take a little time to try to optimize it. Let me just take a look. How many cores do I have? I have 6 cores, and I'm using 1 right now for this. So does it make sense to try to make a thread pool? Rust thread pool. How do we do thread pools? This is something I do kernel programming for a living, so I'm used to just spawning threads. It's a simple function call just to say, okay, throw this function into a separate thread, but thread builder, thread pool builder build. Because op is executing. We're up to 8,000 while I'm looking up thread pools. So Renega Devi, hello, how are you? Welcome to the stream. Creating a thread pool and storing threads. So it's just impl thread pool. There's got to be an easier way to do this. Multiple thread pools. I think it's Rayon, right? Rayon was supposed to be the thread pool thing. Rust Rayon. Yeah. And we have examples, modules, structs, functions. Thread builder, thread pool. Thread pool build error. So let's see thread pool. Is there an example of how to do it? This is deprecated, use thread pool. Yeah, I was looking at this before, right? Thread pool builder build. And I can click, of course I can click on that and get there. Thread pool builder. Renee says, I've been trying to learn Rust last year, haven't had much time, but I got my M1 Pro the other day, so finally getting into some Rust again. Good. Yeah, I've been enjoying, this is not an M1 Pro, this is an older, if you just saw I pulled up the About This Mac thing. This is an older version. I'm still running Catalina on it. So, and Antique. But it does fine. I do want an M1 at some point. We're about halfway done. Let's see if we can figure out. Oh, okay. So you say Rayon, thread pool builder, new, num threads. So we can just throw 6. Maybe I should just do 4 threads. Renee says, I have a similar Intel Mac at work. I mainly do Python. Yeah, I mainly do C. So Rust is strictly hobby language for me right now. Build global. So if I just do this, then how do I run? This is creating a thread pool. And then how do I call? Oh, here's an example. Oh, this is a scoped pool. I don't want to build a scoped pool. This is not giving me very much information on how to. This says how to create a thread pool. But how do I let it run and then gather up results and get results back and stuff like that? I'm not seeing anything in here that shows me how to do that. It's one of the things about Rust docs that I don't like is that it's just, I mean, it's just, yeah, this is the API. So here's the API, but how do I use it? How do I created thread pool. Great, I've got a pool now. I want to submit things to the pool, and then I want to get all the results back from the pool. Meanwhile, this is 3/4 of the way done. Yeah, well, maybe I should say like a Rayon pool example. That's not it. That's not it. FAQ. How many threads? No, that's not the FAQ that I'm looking for. Nothing. Oh, we got an answer. 25734. That's kind of neat. And the result, yeah, so R0 is 6. I'll let it continue running, because why not? I'm not seeing examples here. Rayon, a data parallelism library for Rust. Oh, this is just a, okay. Right, here's par iter. But now I want to create a new search struct and let it run for each value of. I guess I could do that, but I don't want to just. I want to have all the results returned and just get the one result back that I'm looking for. All right. Well, this is almost done. I'll have to look that up later. JDog says it might be easier to use Rayon's par iter. Yeah, that's what they were saying here. But okay, how do I get my results back? I want to map this to. Oh, then I guess I can do like a filter on. Yeah, I should have timed this too. Let's see exactly how long it took. But maybe that's something we can optimize in a little bit. But it looks like we have one answer. Yeah, we're almost done here. 32767 is the last one. Boom, done. Okay, so we have an answer, and there's a single answer, which makes me feel pretty confident in the answer itself. Let's go back to our virtual machine here. And then we need to hack this up, right? What did we do in order to set the value? I think it was when we set the input for the first time. Yeah, we set the register to 1, so we should change it to this new number now that we got. Oh! Right, that was the thing. We actually want to look for that value there before we execute. We want to say if machine.idx is equal to, right? Michonne. If we're at this instruction, then we're going to inject. Oh, that was here, right? We did it here. If machine.idx. Got the OX there. Else, we're going to return this guy, semicolon, right? So this is what we did, and we just injected a return statement. But what we're going to do now is we're going to set machine I forgot the structure already. Register 0 to be 6, and machine register 1 to be, what was it? It was all prime numbers except for the last digit. It was like 27354 or something like that. 25734. Okay. And then we inject the return statement, and that should get us past that part, right? That checks. And we have our commands. I put it in the steps thing here. This @ was to turn on debugging, but I don't want to do that now. So let's see what happens if I say cargo run less than steps. Okay. Starting confirmation process, estimated time. Yeah, so we saw that before, and now we wake up in the sandy beach, and now we have a code. Begins to rain, the message washes away. So hopefully this is the correct code. That would be annoying if it wasn't after all that work. Ooh, okay. That was the 7th code. Okay. I'm not going to tweet about it or email implementation solution notes. This is all on video if people want to see it. Okay. So I think we're almost there. We have one more code to get. So we got to be close. But now we're out of commands here. So what do we do? I need a way to be able to read commands in from a file. And now, because now I want to get to the point where I want to type commands in again, right? So how are we going to handle this? Where do we use buffer read? Oh, yeah, so we have a file thing to read the challenge file, but now I want a file thing to read. I put this all in main, wow. To read in file data. So I can also do let lines. I shouldn't use lines. Commands. FS read to string. Commands text. So what we'll do is just read in all of those and use those as the initial input until we run out of thing, and then we can say lines here, right? Probably have to do an expect. Could not read commands text dot lines. Okay, and this is probably warning us that we're not using it. That's what the W is for. And then where do we do it here? Here. Okay, this we don't need to worry about anymore. Reg is set because we set that up above now when we inject the extra thing. All right, so if curline is empty, then instead of grabbing it from here, we're going to look to see if commands, if not commands, is empty. Then I guess we can set curline is this. We'll say let mut s equals commands remove 0. The reason I'm doing this is because I just remembered now that we needed to we need to add a new line at the end. s.push new line, and then return s. Will this check? Nope. Oh, semicolon. No method named is empty on commands? Really? Isn't this a vec? Tell me what I did wrong here. Oh, do I have to do a collect or something? Nope. Oh, I have to toString it. Map x dot toString. That's probably a better way to do this, right? There we go. Oh, and then it has to be mutable. Yeah. There we go. Okay. JDog says, congratulations. Thank you. That was, I'm guessing that was for the 7 of 8 codes. And sorry, I wasn't paying attention to chat there. So we got 7 of 8. We got the command. So hopefully now what I can do is copy steps to commands.text. And I should be able to say cargo run. And then it should dump me into, yeah. So now I can type in a command. Oh. Why is that a different code? Oh, because the value is 0. Oh no, this is the previous code. I just haven't done the use teleporter yet. Really? I'm confused. What did I mess up? Oh, there's an I don't understand in here. Uh-oh, we're not getting this right. Oh, maybe I don't need to add a new line. Really? Because I think it's saying that on every single ruins. No, it's saying it right here. What do you want to do? What do you want to do? Oh. It's doing stuff. I mean, it's moving, but every other command is I don't understand. Try to type help, and that might be the new line thing. So I just killed this because you know what I'm gonna do is I'm gonna print out each command as I execute it, so I can see what it is. Because I need to be able to. This needs to be able to use the teleporter, right? What's the last thing you do? Yeah, take teleporter, use teleporter. And the use teleporter should then transport me to where I need to go. So after this, I should be able to say what the current line is once we do this. Oh, that's why I'm pushing a new line here already. So I shouldn't need to. There we go. That was the problem. Oh, then all we have to do is this. Right? Yeah, that's better. And then before I push it, I'm going to just say println And then this cur line to uppercase. So it's clear that this is a command coming from, yep. All right, so let's try again, cargo run. All right, so there's take teleporter, use teleporter, and access's value is 0. Wait a minute. Where's the line that's I'm lost, because where's the line that says inside? Oh, now it's just printing out my commands too. That's okay. I've gotten lost, because aren't we supposed to be doing and it's reading as 0. What did I do? Did I break something? Oh, yes, I did break something. That shouldn't be a 0 anymore. We need to set that, actually. I did break this. Okay, so at the first input, we can say machine register 7 is 1, right? That's what it's called. Okay, that's what I broke. Cargo run. There we go. Oh, that's okay. We're good. I don't care about the code anymore. I think that's a different code. But I don't care. We're getting there. So we're on a beach. This is a sandy beach. So this is all new now. In a cave on some tropical island. It's raining. The ocean is to your south, and heavy foliage is to your north. The beach extends east and west. Okay, we can walk along the beach. Sandy beach. It's raining. Okay. Steep embankment blocks to the east. We can go west. Go west along the beach. Okay. So we can go west and then north. Large trees are protecting you from the rain. You can hear birds chirping. There's a steep rock face to your west. So we can go north, south, or east. A small waterfall. Am I going anywhere here? The embankment of the cave come together here to your east and west. Between these tall rock faces, there is a narrow, overgrown path leading north. You hear waves lapping up on a beach through the dense vegetation to your south. Okay, I guess we keep going north. You're on a narrow path between two steep rock faces, which look like they've been here for thousands of years. Rain trickles down through the vegetation and moss. Through the leaves, you can occasionally see a sliver of light hundreds of feet above you where the rock walls end. Uh-oh. I see treasure vault access here. Narrow path slopes downward to the north and leads to the mouth of a small cave. A sign nearby reads treasure vault access, but different handwriting has crossed this out and written, lair of horrible monster, all non-pirates keep out. Okay, I'm a pirate, so I'm going to keep in. You stand at the entrance to a natural cave which looks like it hasn't been visited in quite some time. Light pours in from the opening through the south, while fireflies light the path further to the cave to the north. We still have our lit lantern, right? Yeah, we do. Okay, so I'm not worried about light. Fireflies slowly drift around you and light the tunnel, which seems to get brighter to the south but dimmer to the north. Let's keep going north. The cave is a little wider here. You find a cobweb-encrusted remains of a small camp, and although you don't suspect broken pieces of tables and chairs will prove useful to your quest, the fireflies seem to like using the debris as a shelter. A passageway leads north and south, and there is an alcove to the east. Okay, let's go east. Tropical cave alcove. At the back of this alcove, there's a small table, a chair, and a broken lantern. Looks like this space was used much more recently than the camp to the west. Things of interest. Journal. Read. Journal. Oh, right. I have to say take journal. Oh, look journal. There we go. Oh my god. There's a wall of text. Fireflies were using this dusty old journal as a resting spot until you scared them off. It reads, Day 1. We've reached what seems to be the final in a series of puzzles guarding the ancient treasure. I suspect most adventurers give up long before this point, but we're so close, we must press on. Day 1 P.S. Postscript. It is a good thing the island is tropical. We should have food for weeks. Day 2. The vault appears to be sealed by mysterious force. The door won't budge an inch. We don't have the resources to blow it open, and I wouldn't risk damaging the contents even if we did. We'll have to figure out a lock mechanism. Day 3. The door to the vault has a number carved into it. Each room leading up to the vault has more numbers or symbols embedded in mosaics on the floor. We even found a strange glass orb in the antechamber on a pedestal itself labeled with a number. What could they mean? Day 5. We finally built up the courage to touch the strange orb in the antechamber. It flashes colors as we carry it from room to room, and sometimes the symbols in the rooms flash colors as well. It simply evaporates if we try to leave with it, but another appears on the pedestal in the antechamber shortly thereafter. Okay. It also seems to do this even when we return with it to the antechamber from the other rooms. Day 8. When the orb is carried to the vault door, the numbers on the door flash black, and then the orb evaporates. Did we do something wrong? Doesn't the door like us? We also found a small hourglass near the door, endlessly running. Is it waiting for something? Day 13. Day 13. Oh! Ha! Look at that. 1, 1, 2, 3, 5, 8, 13. Very funny. Okay. Some of my crew swear the orb actually gets heavier or lighter as they walk around with it. Is that even possible? They say that if they walk through certain rooms repeatedly, they feel it getting lighter and lighter, but eventually just evaporates and a new one appears as usual. Day 21. Now I can feel the orb changing weight as I walk around. It depends on the area. The change is very subtle in some places, but certainly more noticeable in others, especially when I walk into a room with a larger number or out of a room marked star. Perhaps we can actually control the weight of this mysterious orb. Day 34. One of the crew members was wandering the rooms today and claimed that the numbers on the door flashed white as he approached. He said the door still didn't open, but he noticed the hourglass had run out and flashed black. When we went to check it, it was still running like it always does. Perhaps he was going mad. If not, which do we need to appease, the door or the hourglass? Both? Day 55. Fireflies are getting suspicious. One of them looked at me funny today and flew off. I think I saw another one blinking a little faster than usual. Or was it a little slower? We're getting better at controlling the weight of the orb. We think that's what the numbers are all about. The orb starts at the weight labeled on the pedestal and goes down as we leave a room marked minus, and up as we leave a room marked plus, and up even more as we leave a room marked star. So I guess subtract, add, and multiply. Entering rooms with larger numbers have a greater effect. Day 89. Every once in a great while, one of the crew members has the same story. The door flashes white. The hourglass has already run out. It flashes black and the orb evaporates. Are we too slow? We can't seem to find a way to make the orb's weight match what the door wants before the hourglass runs out. If only we could find a shorter route through the rooms. Day 144. We're abandoning this mission. None of us can work out the solution to the puzzle. I will leave this journal here to help future adventures, though I'm not sure what help it would give. Good luck. What do you want to do? So it looks like he just explained the puzzle to us. This is like, a day 15 in Advent of Code, where we get the whole explanation here. We can go back west, north. This tunnel slopes deeper underground to the north, but the fireflies are all around. Light your path. North. Okay, here's the orb. You are in an antechamber to a grid of rooms that control the door to the vault. You notice the number 22 is carved into the orb's pedestal. Things of interest here. There's the orb, so we'll take the orb. Let me get out my paper, my notes I was doing yesterday. Okay. And let's see if we can map this out, because we have a 22 in the orb's pedestal. We can go north, east, or south. So I'm guessing this is a square grid of rooms. Because south should take us back to the tropical cave. Let's just double check that theory. Yep. Okay, so if I take the orb, look orb. Oh, it doesn't tell me the weight, but it does say 22. Okay. Use orb. Sure, I'm not sure how to use that. Okay, so let's start with going north. North. The floor of this room is a large mosaic with a plus sign. Okay. Plus. Let's keep going north. We now have a 4. Okay, north. We now have a multiply symbol. Okay. Oh, we can't go north anymore. Okay, east. It's an 8. All right. Let's go south. Let's do this systematically here. South is a star. And I assume that if I go west, it should take me to the room with a 4. Yes. Okay, so east back to the star. I did notice that the orb was changing color here. We said flashes yellow. There was a green here, right? So I was noticing that, but right now I'm just trying to map out the mosaics on the floor of the map. All right, so it looks like we have at least 2 columns here. We got the star south. It's also a 4. South. That's a minus. And we can't go south anymore, so we go east. This gives us a 9. Minus sign. And I'm not going to verify each of the connections. I'm just going to assume that this is a grid until we get proven otherwise. 11. Okay. And a minus. So this actually lines up nicely with all the other rooms. So this looks like, so far it's a 3x4, but we can go east again. This has a 1. Oh, and this is a vault door, not a vault lock. You stand before the door to the vault that has a large 30 carved into it. Affixed to the wall near the door, there's a running hourglass which never seems to run out of sand. So I can say, can I say look door? Look hourglass. No. Okay, so you can only look at things you're actually able to pick up. That's fine. So now we can go south. This has a multiply. South. It's got 18. And then south. It says multiply. And then we can only go north or west. So west should take us back to 9. Oh, west. Yep, and then west should take us to minus, and then west should take us to the 22. And there's the orb. So I must have lost the orb along the way. That's fine. Maybe if the orb gets too heavy, then it disappears. Or something like that. All right, so we know now this is a 4x4 grid of rooms, and I have the map. So what we need to do is find a path, and I'm assuming the 30 just means we have to find a path that results in the orb being a weight 30 when we get to the upper right hand corner of the map. Let's extend our command. Before we do anything else, let's extend our commands to get to the orb room, the vault antechamber. And I think it was just going north a bunch of times. Argo run. Right, we're on the beach. North, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. Okay. So let's extend our commands to do that. 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I run this now, it should get us right to the orb room, and it does. Good. Okay, so this is updates to handle, and I don't want to add these other things. I guess I could add the extracted algorithm. I don't need the output or output 2. Git add source main and commands. Bypass 1 billion year check and read commands from file to get to orb room. Okay. So, given that, we now need to come up with a way let's create a new little program here. Find weight. Cargo new. Okay, so what are we going to do? How are we going to solve this one? We know what the grid looks like. Let me put it here in a comment. So we have a star. An 8. A minus and a 1. I'm getting a little ahead of myself there. And then we have 4 and a plus, and oh, I should make these too big. Okay, there we go. Patatas says, "How's it going?" Hi, Patatas. How are you? We're just working on the final code for the Synacor challenge. So that's 9. That's a star. That's a 4. This is a star. This is 11. Oops. And then this is a star. And then we have a plus, a 4, and a minus, and an 18. All right, so this is what the grid looks like. So I think we just need to do a search, like we've done many times on Advent of Code. Just run the search starting with this, starting the orbit 22, and working our way through the maze. It did say, let me go back to this thing here. Oh, probably, yeah, it's long gone. The journal entry said something about it'll disappear. So let me go back. I think, I just want to make sure. SPM. I remember it saying it's going to disappear. Cargo run. If I say take orb, and I go north, that's going to be add. It's going to be north. It's going to be add. So now it added 4. So if we started at 22, we're now at 26. And then if we say add, and if I say south, yeah, as you enter the room, the orb evaporates out of your hands and it rematerializes on its pedestal. So we're going to add 22 to it, but I guess if you try to enter this 22 room, oh, there. Okay, let me save this. Yeah, so you can't go back to the 22 room. All right, so let's see. Let's create, we're going to have a little state machine that runs through all of the options, all the paths, until we get to the final path that's 30 at the end. I think that would be the best approach. So let's create action, right? So the action can be multiply, add, subtract, or it could be a num. Let's just do I-32. That's fine. And now what we'll do is we'll create a grid, which is going to be a vector of vectors. And it's going to have multiply, num8, subtract, and num1. And then what we can do is we could just go through the whole grid this way. I guess we don't need that space there. This is num4, multiply, num11, and multiply. And then we have, oh, we should add an extra nothing. Sub num9. That way we don't try to do something bad there. And then mul. Okay, and that's the whole vec. Why is it indenting like that? Oh, I gotta use. Okay, use action. I don't want to have to put action on each one of those. Okay, that's fine. Why is it indenting like that? Maybe there's something wrong with... maybe there's a bug in the... If I just put these all together, it still tries to format it this way. Okay, we'll just live with this. Okay, so our starting position, so we're going to create a queue, queue of actions here, which is going to be a vecdec. Oh, we have to pull vecdec in then. Use, is it in standard collections? I think. I know it's supposed to be vecdq, but I say vecdec because that's the way I am. And this is just going to be, oh, we need to have a state, right? We need a state machine. Struct state. And the state is going to have the orb's current value. The X and Y location. So X is usize and Y is usize. Do we need anything else? We'll find out. So it's going to be of state. And we'll say Q push back, and we'll create a new state of our starting state, which is off the screen here. It's going to be state. Orb's value is going to be 22, X value is going to be 0, and Y value is going to be 3. Right, so now what we're going to do is say while Q not, Q is empty. We're going to pop the state. Pop. Well, for pushback, we want to pop front. Right? And now we're going to see if there's an operation we're doing. Because if we're in this state, we want to add, we want to set up the command. Right? Because we have these actions. We want to set up whatever actions we're going to do. Which means we have to add that here. Like that. Right, so if we come here, for example, we want to see if it came from the multiply, or this add. And that's what's going to be in our state. If there's nothing, then we don't have to worry about it. So we're going to say let current action is going to be equal to the grid of the state we just popped, except it's going to be yx, right? Because we're going to index by y first, by row, and then by column. Okay. So match cur act. If we're doing an add, then we want to add. Oh no. We want to match on the where we came from, act, S act. So if we said to do an add, then we want to take the current orb's weight, which we need to get from state, let mod orb, as to orb. So orb plus equals the current act. The current act should be a number then, right? If let number value current act. There we go. Val. Right? I think I'm doing this right. So we grab the current action, and if the current action is a number, then we want to take the previous state's action and apply it to the current number on the orb. So there's add. Mul is going to be orb times equals val. Sub is going to be orb minus equals val. And everything else we'll just ignore. And this might come back and bite us, but I'm going to worry about that later. That's a problem for future scientists to deal with. Okay. So now, if our resulting orb, so we just hit this number, right? We may have hit here. If s dot x is equal to 3, right, 0, 1, 2, 3, and s dot y is equal to 0, and orb is equal to 30, right, we were looking for 30, then we're done. But we don't know how we got here. Okay, so that means our state is going to have to keep track of the history of all of our actions. Right? So somewhere in here we'll have to say print then the history. S.hist. Right? So now, if that's, and then we just break because we're done. We found a path. Let's say, okay, so if this is not true, if it's not a number, then we want to do what? I guess we ignore it, because what we're going to do is create new states to push onto the queue. That's why we're doing this breadth first search, right? So we're going to say, can we go north, right? If s dot y is greater than 0, right? And then we can go north. So we're going to have to actually create a new state here, right? We're going to have to create a new history. This is probably the easiest way to do it, right? And then just say hist push north. We're moving north, and then say q.push back. I'm going to create a new state of orb, which we just got the new value of orb. The x is still going to be s.x because we're going north, but y is going to be s.y minus 1. Our action is going to be the current action. Oh, and then we have to add history, right? Hist. Right? So that's if we can go north. Let me split this display here because I want to look at the grid while we're doing this. If s.x is less than 3, right, then we can go east. So it's just east. Is going to be s.x plus 1, right? and act is cur act and hist. Okay, now we need to be able to go south, but we don't want to go back to this room here. So if x, y is less than 3, right? But if s dot x is not 0, we don't want to go here. So we can just say and, right? Then we say let mut hist is equal to hist clone, hist push south, and then we can create a south here, which is sy plus 1, and then we do the same thing for going west. If s dot x is less than 3, greater than 0, and s dot y is not equal to 3, so it's kind of the reverse. And we'll say this is west, s dot x minus 1, s dot y, and that. So those are all of our pushes. Is that it? Is that all the code? And then we just pop. I mean, I've written how many of these for the last couple advents of codes, so this should be pretty much hardwired into my brain here. Oh right, you got to toString all these guys. It doesn't like this. Move occurs because type action does not implement copy. Well, that's easy enough. Oops. TK built-in commands. There we go. Action derive. And in order to get copy, you need clone, I think. That checks. Oh, let's spread all this out. Don't tell me this worked first try. Don't tell me this worked first try. That would be insane. Okay, so let me cargo run over here. Okay, so take orb. North, east, east, north, north, south, west. I'm watching here just to make sure the orb doesn't disappear on me, right? North, east, east, west. Oh. No, okay, so it didn't work first try. Unless I typed them in wrong. Let me try one more time. North, east, east, north, north, south, west, north, east, east. Oh, I forgot to take the vault, the orb. Take orb. I was wondering what was going wrong there. North, east, east, north, north, south, west, north, east, east. And I think this is where it fails, right? Because we shouldn't be going to this room. Yeah, the orb evaporates out of your hand. So we can't use this as a solution. How many? 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. All right, so that's not a solution. What's the bug? Where did I go wrong here? So we're at 22. North is add 4, subtract 18. So it's 22, add 4 is 26. Subtract 18, which is 8. Right? I can't do math in my head, so I'm getting things wrong now. Multiply by 1. Why do that? J-Dog says, can't have an operator not followed by a number. Yeah, I think the way the grid is designed is you can't do that, right? If you're on this number here, you're going to have an operator. And if you're an operator, you're going to have a number next because there's no diagonals. All right, so north means add, east means 4. So we got to 26. East means subtract. Oh, north means 11. I messed that up. So subtract. Then north is 11. So that takes us to 15. I'm doing 18 times. Maybe. Let's see if we get there. Then north is minus. South is 11. So that takes us to 4. West means multiply by 8. So 4 times 8 is 32. Then east is subtract 1, 31. And then west east is subtract 1. So it does get to 30. It just gets to that vault room twice. Yeah, I don't think there is a way to do 18 times, because once you're on 18, you go to times, and then you can either go to 1, 11, or 18. And here, if you're on times, you can either go to 18 or 9. So there's no way to say times and then times again with this grid. It is getting us to 30, but we're not allowed to enter this room twice. So there's a bug. What's the bug? We need to be able, yeah, so I break as soon as we hit 30. Oh, I need to stop. If we hit this room, then I need to stop as well, right? So if s.x is 3 and s.y is 0, then we can't be here. We can't, oh, continue. We can't continue looking for solution once we hit this location. So we're going to give up at that point. But that takes away our only solution. Right? It's going to come up with nothing now. Oh no, it came up with a different solution. Should I not break? Should I just print them all? Once we hit a solution here, I can just continue from here and see if there's more solutions. I guess there's infinitely many paths. So we know that how long is this? 1, 2, 3, 4, 5. Well, I don't know how many. What's the maximum path length? Let's clamp it. Or his.len, s.his.len. Let's say 20. That should limit the search space. You know, we can try this one. North is plus, east is 4. Oh, I found it. It's finding more, but they're longer ones. Whoa. Okay. Stop. Done. You're done. Okay. So let's try this first one. North. So we start at 22. We go north, which is plus. We go east, which is 4, 26. Same as before. Then we go east, subtract. North, which is 8, 11. So we go down to 15. Then we go west. So multiply by south, which is 4, 60. Then we go east, which is subtract. And then east again, which is 18. Takes us to 42. Then we go west, which is subtract north, which is 11, which takes us to 31. North, which is subtract, and then east again, which is 30. Okay, so that might be the solution then. And just happened to be the first one. North, east, east, northwest, southeast, east, west, north, north, east. Oh, you know what I forgot to do? Take orb. You know what I can do is just put them in commands. And see what happens. So we did this, take orb, and then we'll just grab this line here and paste it here. And then oops. There. Okay. As you enter the room, the orb briefly flashes red. The number on the floor vibrates strangely beneath your feet. The orb seems to get lighter. As you approach the vault door, the number on the vault door flashes white. The hourglass is still running. It flashes white. You hear a click from the vault door. The orb evaporates out of your hands. Nice. You stand before the door to the vault. It has large 30 carbon. Oh, yeah, okay. So now we can go vault, right? The vault contains incredible riches. Piles of gold and platinum coins surround you, and the walls are adorned with topaz, blah, 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 blah. Allurium 15. Now I'm curious. What the hell is Allurium 15? It's the energy source for all alien technologies. Oh, it's an XCOM reference. Okay. Neat. I like XCOM references. And unobtainium. Of course it does. Things of interest here are mirror. There's one exit, leave. Look, mirror. It's a rather mundane handheld mirror from an otherwise magnificent vault room. What use could it possibly have? Use. Okay, so I have to use it. Take mirror. Use mirror. You gaze at the mirror and see yourself gazing back. But wait, it looks like someone wrote on your face while you were unconscious on the beach. To the mirror, you see this. So this is a code. Yay! Okay. Local scientist. Put the code in. That's not a valid code? Oh! I'm looking in a mirror, right? So it's got to be the opposite. WXIIADOXQL8X. All right. Let's try that. Now I got to try in 22 seconds. All right, is 22 seconds up yet? This, I think we found the path. So as long as, how long was it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So let's limit it to 12 and see if there's multiple paths. That are 12. Okay, so submit code. It's still not a valid code. Oh, could it be that it's a mirror? So the IIA, instead of a D, this should be a B. OX, and instead of a Q, it's a P. L8X. Is that it? Is that it? I don't have code 8 yet, JDog, but hopefully this is the final one. Very sneaky, sis. Okay. Hopefully this is it. Hopefully that was the problem. Yeah, okay, so there is only one code that's... how long does it take to find it in release mode after finding all of them? Three seconds. That's not too bad. The other one takes longer, right? Algo. Cargo run release. Yeah, this takes forever. I wonder if it's worth putting it to Rayon at this point. I do have 6 cores. Okay, let's see if this was the code. Yay! You've collected all 8 codes. Congratulations. Please email me your implementation, solution notes, and challenge feedback. I'd love to hear about your journey. Synacor is hiring. Are they? Are they still hiring? Locations. Buffalo. Buffalo, Buffalo. Buffalo, Buffalo. Ooh, maybe they'll move me to London. That would be cool. Tokyo. I don't speak very much Japanese. Skoshi hanashimasu. Demo mada jouzu ji arimasen. All right. That was cool. That was cool. That was a lot of fun. I guess the only other thing here is whether or not we should try to speed this up with parallel searches. So that's what I was doing before. I was saying, how do we do Rayon thread pool? Right? We were looking this up, and I didn't have a good tutorial on this. Oh, well, this might be exactly what we're looking for. Right? Yeah, J-Dog says, wow, code 8 of 8 was fast. Congrats. It was fast, I guess, compared to code 7. Code 7 was slow because I had very poor implementation, and then once I had a day to think about it, I was able to bang something out really quick. Code 8 was fast only because they basically explained the entire thing in the journal, what to do. And it said it was time limited with the hourglass, and we had to get the exact weight, so and you knew it was just a breadth first search, which I've had a lot of practice doing over the course of several advents of code. All right, I think this is what we want. Cargo add Rayon. So let's throw Rayon in here and see if we can come up with... Meanwhile, let's have it running here. And I've reached the end of the challenge. So we're all done with that. So let's go over here to Algo. Cargo run. I'm going to say time. Cargo run release. Oh, is it going to be... Yeah, it's building Rayon. Damn it. So let's let that finish. But the time is not going to help me. I want to see how long it takes with the single thread, and then we're going to add these threads using this thread pool. And what I'll do is just create... This has 4. I guess 4 is a good number. Oh, that's main. So we can just do this here, right? Let num threads is 4. Yeah, so this has the machine I'm on has 6 cores, but I don't want to use all 6 because I am using cores to run the music and OBS and everything else. All right, so let me start this again because now it's not going to build Rayon. Yeah, it's about, I mean, if you look at the hundreds digit there, it's about 100 searches per second, which is pretty good. But let's do this while that's going on. So we have the pool. We don't need the files. We're getting the numbers here, right? And we just need this. MPSC, I don't know what that stands for, channel. Because this looks like it's doing exactly what I want. It creates the thing, it sends it, and then we could just collect the data here, right? We don't want to print that out anymore, or that. We create the let tx is tx clone, pool at spawn, move this, and it's just going to be this. We can get the result, and then if the result, oops, is 6, we can send it. tx.send R7, right? So all we're doing is sending back unwrap, right? Unwrapping the send, yeah, okay. Otherwise we don't do anything. And then here we say drop tx. I'm just following this line here. And then we want to say let results equal rx into iter collect. And it looks like we have to tell it it's a vec of, what is this? Oh, this is a U size. I have a U16 here. So let's just make it a U16 like that. Does this check? Does not. Oh, because I didn't finish this thing. There's a spawn close like that. Doesn't like this. Attempt to take value of method collect on type into iter. I obviously don't know. Oh, I forgot the parens. Yeah, okay, and now we have. Oh, we're not using those guys anymore. Okay. Good. All right, so this is still going. Should we let this finish before I kick off a new one? I don't know how long this will take. I mean, if this takes like 10 minutes, that's kind of annoying to sit here and watch. Meanwhile, maybe what I can do is think about, if I want to push this up to my GitHub, there's a bunch of stuff in here. We don't need the Synacor challenge anymore, right? People can download that from the thing, but if I say git status here, this is not a git repo, but I can say, what can I do that will avoid this on wiping out all of my code? Because if I say git init, it's because it's created an empty git repo, reinitialize an existing one. I don't want to blow away any of my files here. Maybe what I can do is this, is say GitHub, and I can just create a new repo and call it Synacor. Oops. Like that. Create repo. And then I can and then I need to clone it. Git init will not delete anything. You say that, but then what happens if it does? Right? CF. Let me just tar it up, and then I'll go ahead and do it. Ooh, that's going to tar up all the targets too. Oh, that's all right. I guess that was fast. Okay. Git init. How I forget how I did the thing. RT git config. So it's just GitHub colon. Okay. So I should be able to just do this. Right? And change this to, oops, I guess it's remote origin. Git add remote origin this. Nope. How do you do it? Oh, remote add. I am not a Git user by any means. My day job, we use a different thing. So now I should be able to say git push -f, right? Remote origin or origin remote or something like that. Oh, git push. Nope. Yeah, I don't know what I'm doing. I added the remote. So it's there. I guess I can do this. Okay, so that ran all the way and it took 400 seconds. So 6 minutes, almost 6 minutes. So let's try this cargo. So now I should be able to say time cargo run release, and it should get the Rayon version of it, right? Oh, it's compiling it though. And we don't see the output, unfortunately, but we can let it time while I'm doing this craziness over here. Git push set upstream origin main. No, I don't know what I'm doing. Git force overwrite remote. Git push this of remote branch. Git push -f origin main. Nope. Git status. Git add dot. Yeah. You've added another Git repo inside your current repo, and clones of our repo will not contain concepts of that embedded submodules. So now I have to do submodule. I don't know how any of this works. Git submodule add URL. Find wait doesn't have a commit checked out. Okay, I don't know what I'm doing, so I'm not going to keep doing it. Oh, but this finished. Yeah, so using Rayon, multi-threading it only took 200 seconds instead of 400. So it split, it reduced the amount of time by 2, which is pretty good. Right, this used 97% CPU, so it was using a single CPU, right? This used 383, so almost 4. Okay, so that worked pretty well. So you know what we're going to do is we're going to wrap things up here. And call it a stream, and then on Monday we're going to get back to doing where's my other window here? There it is. We had been doing all of this roguelike stuff, and I want to get back to this roguelike stuff. So we took the week to do the Synacor challenge. The Synacor challenge has been done. We got decent solutions for everything, and I think we're good to go. So let me see. So we'll call that a stream, and we'll end things right there. A little early for me, but that's good. I hope everybody had a good time. I did, and I will figure out this Git thing offline and get it all pushed somehow. I'll have to learn how to do that with sub repos somehow. All right, take care, everyone, and have a great rest of your day.